Hello, everybody. Welcome back to Algebra 2. This is the beginning of several days of graphing rational functions. If you look at that word rational, remember it starts with ratio. So these are going to be functions that we're graphing that have fractions in them. So we'll do like we've always done. We'll look at the parent function and then see what that looks like and then apply some changes to it to see how that moves the graph around the coordinate system and changes its shape. So this is the easiest parent function I can come up with, y equals 1 over x. So let's just kind of mentally plug in some points in for x and then calculate y. So let's say x is 1. If I make a little table here, x is 1. Then, of course, y is going to be 1. So we have a point right here. Now, I want you to think about what happens as x gets bigger and bigger and bigger. So I'm not going to write all these in the table, but let's say x is 2, then y is 1/2. X is 3, y is 1/3. X is 4, y is 1/4. So as x gets bigger and bigger and bigger, y gets smaller and smaller and smaller. So your graph would look like this as x gets bigger. So we talked about that before. So that x-axis there is going to be a horizontal asymptote. Horizontal asymptote. So that asymptote is y is equal to 0. That x-axis is y is equal to 0. The graph will get closer and closer to it, but never touch it. It's like an electric fence. Now let's think about putting in some numbers that are between 0 and 1 to see what happens. So let's say I put in 1/2 in for x. Well, 1 divided by 1/2 is 2. So if I put in 1/2 for x, I get 2 for y. Let's make x go to 1/3, then 1/4, and 1/5. Think about what's happening to y. So if I get x is 1/5, y is going to be 5 because 1 divided by 1/5 is 5. So as I get closer and closer to 0 from the right side, as those fractions get smaller and smaller and smaller, those y coordinates actually get bigger and bigger and bigger, like that. But notice that x can never be 0 because you cannot divide by 0. And so that means that the y-axis right here is a vertical asymptote. The y-axis has coordinates of x equals 0. So this graph has a horizontal asymptote for the x-axis and a vertical asymptote for the y-axis. Now let's think about plugging in some negative numbers for x. Let's plug in -1 for x next. So if I put in -1 for x, 1 divided by -1 is -1. So we got -1 with -1. So here's a point on the graph also. Now let's think about what would happen to y if I plug in -2, then -3, then -4, then -5 for x. Well, y is getting smaller, but the fraction is negative. So as x gets smaller, like -2, -3, -4, as x gets more and more negative, y is getting smaller, but still negative. So this graph over here would approach the x-axis from underneath. And so that x-axis is still a horizontal asymptote, but the graph is underneath it. Now let's think of plugging in numbers for x between 0 and -1. So like -1/2. If I put in -1/2 for x, y is going to be -2 because 1 divided by -1/2 is -2. So if I put in -1/2 for x, y is -2. Think about putting in a number like -1/10 for x. That would be 1 divided by -1/10, which is -10. So as your points you choose for x get closer and closer to 0, y gets really, really small and negative. So the graph would go down like this. So this is a graph which has actually two branches, and there's a gap. It's not a continuous graph. There's a gap in there. So let's talk about domain and range. Domain and range follow the asymptotes very closely. So remember the domain is what can x be. So if you look at that equation, x can be any number you want except for 0 because you cannot divide by 0. So we can say the domain basically is x is any number so except for 0. So we can write it like that, x is not equal to 0. So notice that's also coincides with the y-axis. So the vertical asymptote, which is the y-axis, the graph cannot touch that y-axis in the same way that x can never be 0. Okay, look at the range. So that's asking the question, what can y be? We'll look at it first from the standpoint of the equation. Remember, y is equal to 1 over x. y will be 0 when the top of the fraction is 0. Well, the top of the fraction is a constant, 1. So the top of the fraction will never be 0. There's no variable up there. It's always 1. So the top of the fraction will never be 0, and therefore the fraction will never be 0, and therefore y will never be 0. So we're going to say the range is y is any number you want except for 0. So y is not equal to 0. And again, you can also get that information from the graph. On the x-axis, all the y coordinates are 0. Y can never be 0. So that graph never crosses the x-axis, never touches the x-axis. Okay, so what I've done is enlisted the help of our friend Desmos to show what happens when we make some changes to the parent function. And so the first graph you'll see is y equals 1 over x. So you can see it right there. That's the graph we just graphed. Okay, now look at the second one right here. We know that when you take a parent function and put a number on the end, whether it's plus or minus, you're going to move that graph vertically. So if this is plus 2 on the end of the graph, it's going to move that graph up 2 squares. Every single point gets moved up 2 squares. And you can see that's what happened right there in the blue graph. Also, in the third equation here, notice we put a minus 1 on the end of the parent function. That means every single point in that graph is going to be moved down 1. So this one's going to be moved down 1 from the red graph. And that's what you see right there. Okay, so no surprises there. The parent function moves up or down based upon the number on the end of the equation. Okay, let's erase those two and look what happens in this next one right here. So there we have a number added or subtracted from x. And we've seen from a bunch of different functions before that indicates a sideways motion of the graph, and it does so counterintuitively. So if you subtract 2 from x, you're going to take that parent function and move it every single point 2 to the right because it's x minus 2. Let's see if what happens here. Yep, so the blue graph is exactly the same as the red graph, only move 2 to the right. Look at what happens on this next graph. Same exact function with parent function, except your graph now has your equation has x plus 1 at the bottom. That's going to take that parent function and move it 1 square to the left. So you're going to see that red graph gets moved 1 square to the left. That's exactly what happened there. Okay, now, as usual, what we've done this year, all year, is we've put a couple changes in together in the same equation. So look at this one. So this time we've moved the graph 2 to the left because of the x plus 2 in the denominator and 1 down. So you're going to see every point on the red graph move 2 to the left and 1 down because we've changed the equation. So that's what happened there. Okay, let's erase that one and look at this next one. So this next one, so we have a negative sign in front of the parent function. So we know that simply reflects the graph in the x-axis. So all those points that are above the x-axis you see then on the right side of the y-axis there in the first quadrant, those are going to be reflected down across the x-axis. And all those points on the branch of the graph in the lower left-hand quadrant, those are going to be reflected up. Exactly what you see there. So the red graph is reflected up and down across the x-axis because of that negative sign. Okay, so last thing we have to deal with here is what happens if you multiply the parent function by a number. So we have y equals 3 over x. That's the same as y equals 3 times 1 over x. We just wrote it as a single fraction. And if you remember for other functions, what that did was it did a vertical stretch. So every single point, for any given x, the y coordinate is multiplied by 3. So that means on the top, on the positive part, the right side of the graph there in the first quadrant, all those y coordinates are going to be multiplied by 3. So it's going to be stretched upward. But on the left side of that graph, where the y coordinates are negative, when they get multiplied by 3, then they're moving down. They're getting stretched in the downward direction. So let's see what happens there when we graph that one. So it's exactly what happened as we predicted. Okay, so we're going to stretch this assignment out over 2 days. So what I'll do on the assignment that you can download is do one of the problems, and then if you're feeling ambitious, you can do the rest of them, I think, based on that one. If you want to wait till the next day, I'll do a couple more examples, and then you can maybe that'll help more. But basically, I'll do 3 examples today and then the next day, and then the 10 problems altogether just we'll be doing the second day. Okay, let's take a look at example number 1. So our equation, I'm going to replace that f of x with y, so we know that's the same thing. So that's y equals 2 over x plus 2 and a plus 1 on the end. Okay, so actually 3 different things have changed from the parent function. First of all, the 2 simply stretches a vertical stretch, so that's all it does. The x plus 2 moves our graph, our parent function, to the left, and the plus 1 on the end, of course, moves it up 1. So the way we're going to graph these is by putting in first the asymptotes instead of just plotting a bunch of points. And that'll give us a good enough graph for the equation. Okay, so remember that normally the vertical asymptote, if you look back earlier in this video, the vertical asymptote was at the y-axis. So now it's going to be moved 2 to the left because of the x plus 2. So I'm going to put in a vertical asymptote there. I'll put that in blue ink. So there's your vertical asymptote. Remember, your graph is not going to touch that. And then the plus 1 on the end moves that horizontal asymptote up 1 from the x-axis. So remember, it used to be at the x-axis, but now we've got that plus 1 on the end. So all the points are going to be moved up. And so that horizontal asymptote now is going to be right here, up 1 from the x-axis. So the directions say they want the horizontal axis and the horizontal asymptote and the vertical asymptote. This is y equals 1. All right, because it's horizontal. This is x equals -2. So there's how you give asymptotes are lines, they have equations. Okay, so now we haven't even drawn the graph yet. So what we're going to do now is put the graph in somewhere using these asymptotes. So here we're going to have to make a short table and choose a point. Remember, the graph has 2 branches, and so it's going to have a branch to the right of the vertical asymptote, and it's going to have the other branch to the left. But it's not going to touch either asymptote. So I'm going to choose a point that's easy to calculate with, that's clearly on the right side of the vertical asymptote. So I'm going to make up a number, let's say 0 for x. That's going to be easy to calculate. Look at your equation. You got 0 plus 2 is 2. So 2 divided by 2 is 1. 1 plus 1 is 2. So 0 is going to be paired off with 2. I can put that point in there right now if I want. I'm going to put that in red there. Okay, so 0 goes with 2. Now I know just from that one point where to graph that branch, because it's going to look like a boomerang. It's going to look like this because it's going to go through that point we just found, and it's going to approach the horizontal asymptote but never touch it, and it's going to approach the vertical asymptote and never touch it. It's got that boomerang shape. So that branch I know is right there based on that one point because it cannot cross either asymptote. Okay, now I need to find a point on the left side of the vertical asymptote. So again, I'm going to pick a number for x. I can choose anything I want, but looking at the equation, I want to pick something that's easy to calculate with. All right, so I'm going to choose, how about, let's see, -3. Because if I put a -3 down here for x, you can do the math with me mentally. -3 plus 2 is a -1. 2 divided by -1 is a -2. Plus 1 is a -1. So I put in -3 for x. I did the math there. -3 plus 2 is -1. 2 divided by -1 is -2. Plus 1 is -1. So at -3, -1, I have another point on my graph. So 1, 2, 3 right there. Now again, that's all I need to be able to draw that branch of the graph because I know it's trapped in there. It's going to be to the left of that vertical asymptote, and it's going to be underneath that horizontal asymptote. So I can sketch it in there. It's going to approach both asymptotes like that. These all have boomerang shapes. And so that's all I need. That's going to be a good enough graph for that equation. Okay, so the directions, remember, we got to follow directions. So we've already talked, you've seen the 2 asymptotes. They're given there with their equations. And let's also talk about domain and range. And that's easy once you know the asymptotes. So the domain is everywhere x can be any number except where you see that vertical asymptote. So we would say the domain is x is anything except for x is not equal to -2. And by the way, look up at your equation. Do you see why x cannot be -2? Because if x is -2, you have division by 0, which is not allowed. So x cannot be -2. You can tell from the equation and from the vertical asymptote. The last thing we have to know is the range for this problem. And so the range is what can y be, or what may be easier to say, what can't y be? Look at your horizontal asymptote. Y cannot be -1. I'm sorry, y cannot be +1. Because that's where the horizontal asymptote is. So y cannot be +1. All right, so there you go. If you want to work ahead and do the rest of the problems, go ahead. There's 10 of them. If you want to wait, I'll give you 2 more examples on the next day, and then you can turn them all in then, just up to you. All right, so there's our first introduction to graphing rational functions. Enjoy.